Hello friends, welcome to our video. I am Akshay with my team members Darshan, Amar and Shivling present the explanatory video of our project. We are third year computer engineering students from GH Rai Soni Institute of Engineering and Technology, Pune. Let's we start with our video. Machine learning is used across many spheres around the world. The healthcare industry is no exception. Machine learning can play an essential role in predicting absence of locomotor disorders, heart diseases and more. Such information, if predicted well in advance, can provide important insights to doctors who can then adapt their diagnosis and treatment per patient basis. In this video, we will discuss a project where my team worked on predicting of heart diseases in people using machine learning algorithms. The algorithms included logistic regression, support vector machine, decision tree classifier, random forest classifier and naive Bayes. The dataset has been taken from Kaggle. Complete project is available at GitHub. First step is importing required libraries. We imported several libraries for the project: NumPy, to work with arrays; Pandas, to work with CSV files and data frames; Matplotlib, to create charts using Pyplot, define parameters using recurrence and color them with CMRainbow. Next, we imported all the necessary machine learning algorithms. Second step, importing dataset. After downloading the dataset from Kaggle, we saved it to my working directory with the name dataset.csv. Next, we used read CSV to read the dataset and save it to the dataset variable. But for any analysis, we just wanted to take a look at the data. So, we used the info method. As you can see, there are a total of 13 features and one target variable. Also, there are no missing values, so we don't need to take care of any null values. Next, we used describe method. The method revealed that the range of each variable is different. The maximum value of age is 77, but for Cholet is 564. Thus, feature scaling must be performed on the dataset. To understand the data, we use correlation matrix, histogram and some other plotting methods. Correlation matrix. To begin with, let's see the correlation matrix of features and try to analyze it. The figure size is defined to 12x8 by using recurrence. Then, we used Pyplot to show the correlation matrix. Using STIX and ITX, we added names to the correlation matrix. COLOBA shows the COLOBA for the matrix. It's easy to see that there is no single feature that has a very high correlation with our target value. Also, some of the features have a negative correlation with the target value and some have positive. Histogram. The best part about this type of plot is that it just takes a single command to draw the plots and it provides so much information in return. Just use dataset hist. Let's take a look at the plots. It shows how each feature and label is distributed along different ranges, which further confirms the need for scaling. Next, wherever you see discrete bars, it basically means that each of these is actually a categorical variable. We will need to handle these categorical variables before applying machine learning. Our target labels have two classes, 0 for no disease and 1 for disease. Step 3, data processing. To work with categorical variables, we should break each categorical column into dummy columns with 1s and 0s. To get this done, we use the getDummies method from Pandas. Next, we need to scale the dataset, for which we will use the standard scaler. The fit transform method of the scaler scales the data and we update the columns. The dataset is now ready. We can begin with training our models. Step 4 is training and testing of model using machine learning. In this project, we took 5 algorithms and varied their various parameters and compared the final models. We split the dataset into 70% training data and 30% testing data. Logistic regression. Logistic regression is a classification algorithm used to assign observations to a discrete set of classes. Logistic regression transforms its output using the logistic sigmoid function to return a probability value support vector classifier. This classifier aims at forming a hyperplane that can separate the classes as much as possible by adjusting the distance between the data points and the hyperplane. There are several kernels based on which the hyperplane is decided. We tried 4 kernels, namely linear, poly, RBF, and sigmoid decision tree classifier. This classifier creates a decision tree based on which it assigns the class values to each data point. Here, we can vary the maximum number of features to be considered while creating the model. We range features from 1 to 30, the total features in the dataset after dummy columns were added. Random forest classifier. This classifier takes the concept of decision trees to the next level. It creates a forest of trees where each tree is formed by a random selection of features from the total features. Here, we can vary the number of trees that will be used to predict the class. We calculate test scores over 10, 100, 200, 500 and 1000 trees. K-neighbors classifier. This classifier looks for the classes of k nearest neighbors of a given data point, and based on the majority class, it assigns a class to this data point. However, the number of neighbors can be varied. We varied them from 1 to 20 neighbors and calculated the test score in each case. Naive Bayes classifier. Naive Bayes classifiers are a collection of classification algorithms based on Bayes' theorem. It is not a single algorithm but a family of algorithms where all of them share a common principle, that is, every pair of features being classified is independent of each other. Conclusion of the project. The project involved analysis of the heart disease patient dataset with proper data processing. Then, 5 models were trained and tested with maximum scores as follows: Logistic regression classifier, 80%. Support vector classifier, 67%. Decision tree classifier, 71%. Random forest classifier, 45%. K-neighbors classifier, 67%. Naive Bayes classifier, 80%. Logistic regression classifier and naive Bayes classifier scored the best score of 80%. Here, we done with our project. We would like thank you Mr. Himanshu Deshmukh for all your support and encouragement. We hope that we can look forward to working with you again in the future. Thank you for watching. Feel free to share your thoughts and ideas in comments.